Last week I showed you this rare Adlib clone card which you couldn't buy even if you wanted to, but this week we're going to repair this and see what it sounds like. I've already replaced all of these electrolytic capacitors here and this chip as well because there was noise coming over the bus, but no change for this card, so where do we start? Well, we know that this is the OPL2 chip, and it turns out that this one is a digital to analog converter. It converts from the digital signal into an analog signal that we'd be able to hear. And this little chip down here, the LM386, well, that's an amplifier. I think that chip is working because when I turn the volume control, the amount of noise goes up and down, but no music, unfortunately. So my best guess is that this one is broken, but before we go poking around, why don't we connect an oscilloscope up to this and see if we can see anything on the input to that amplifier chip. I've pulled up the data sheet for the LM386 amplifier chip and it shows the input on pin 2. So if we connect an oscilloscope to that and see a signal and we see nothing on the output, then we'll know that this chip is broken. Well, not so fast. It turns out there are two inputs to this chip and pin 2 is connected to ground. This is pin 3 and yeah, I suppose there's some kind of signal there, but I couldn't tell you whether this is the sound we want to hear or just the buzzing noise that we heard in the previous video. Yeah, I don't know what to say exactly at this point, but this card works just fine. A friend of the channel, Jim Leonard, suggested that first of all I should try it on a 286 because the Adlib is quite timing sensitive and I was using it on a Pentium in the previous video, so this might not have been the best idea. That wasn't the issue, but he also suggested that we try out something other than this A10 tank game, which is supposed to support the Adlib, and he was right. This game really just doesn't seem to work at all, so I don't know what they've done wrong here. But he also suggested that we try this Adlib program, and as you can see, it works just fine. So I think we can go ahead and just try this card out. Guys, this Adlib program is pretty wild. You've got to try it out if you've got an Adlib compatible card. I'd love to be able to play you all of the sample tunes, but I'm just going to play a short section from each of my favorites. I think you can agree that's amazing. It seems like there are 9 voices here, and these letters C here seem to correspond to the instruments. So we've got C000 all the way up to CFFF, which is just a huge number. And there are also special effects and all sorts of slides and so on. So this is an amazing program, but what exactly is the Adlib actually capable of? I looked up the OPL2 and yeah, it has 9 channels of sound, or you can sacrifice 3 channels and get an additional 5 percussion instruments. So there's actually 2 oscillators per channel, and you can set the frequency of those relative to one another, and there's 2 different ways of combining them. You can either just add those together, or you can actually use frequency modulation, which is where one controls the frequency of the other. So then there's 4 different waveforms for those oscillators. So you can use sine wave or half sine wave, you can use a half inverted sine wave, or there's this kind of cut sine wave. So you get all sorts of different sounds. And then there's actually an envelope generator for each oscillator, so you can control the attack, decay, sustain and release of each note. And then there's a whole bunch of effects like vibrato, tremolo, and sustain. And there's other things as well which I haven't covered, but yeah, this is a really sophisticated chip. There's like hundreds of registers. But hang on a minute, didn't we discover in the previous video that this ALS 4000 sound card also has Adlib features? We're going to try that out with the Adlib program. And stay tuned guys, because I've got some genuine Yamaha chips to try in the clone card. Of course, we're back to my Pentium 233 MMX machine because that ALS 4000 card goes in a PCI slot. I did need the DOS drivers to make this ALS 4000 card work with Adlib. It does work, but the volume is too low. I have my speakers turned up full and every level in the card at maximum. So I don't know what's going on there, but I'm just going to adjust the volume in post. So let's listen to some of those tracks that we heard earlier for comparison. Let me know what you think in the comments, but to me it sounds a little bit tinny and a little bit flat compared to the Adlib clone. So let's go back to that clone card and try some genuine Yamaha parts. At least I think these are genuine parts. I see no evidence of grinding on the top of the chip, especially around these circles. This one looks like it was made in 2010. Maybe that was too late, you tell me. When I rub with IPA, nothing comes off, and I've given both of these a really good scrub. It seems like these are actually laser etched. So what's your opinion? Do these look like genuine chips to you? My impression is that they are, so I'm going to go ahead and put them in the clone card, and we'll see if they sound any different to the chips that were in there. At least these chips are socketed, so it should just be a matter of slipping them in. Now, the original ones didn't have Yamaha markings, so these are definitely going to be different if they're not exact clones. So let's see how it sounds with those in there. It's probably a bit hard to tell on video, but to my ear the instruments sound a little bit more natural, the dynamics are a little bit better, and everything's a little bit cleaner. So I actually think the Yamaha chip is better than the one that was in the original clone card, but they are pretty close, to be honest. Anyway, that's really all I have time for this week. If you enjoyed this, don't forget to like and subscribe, and we'll see you in a later video. Bye!